So our first question is, in spherical polar coordinate r theta phi, the unit vector theta cap. We have to find the unit vector theta cap, okay, at 10, pi by 4 and pi by 2. So r equal to 10 and theta equal to pi by 4 and phi equal to pi by 2. Okay, so we have to find this theta cap. So we know in spherical polar coordinate r cap equal to del r vector by r. And the r vector is what? R vector is r sin theta cos phi I cap plus r sin theta sin phi j cap and r cos theta k cap. Along the x axis it is r sin theta cos phi, along the y axis it is r sin theta sin phi, along the z axis it is r cos theta. Okay, so theta cap equal to 1 by r del theta of this r. So if you derivative this with del by del theta, you will get this sin theta will come cos theta, this sin theta will come cos theta, and cos theta will come minus sin theta. Okay, now you got this theta cap. So now put the values that r equal to 10, theta equal to pi by 4 and phi equal to pi by 2. So I just put these values that theta equal to pi by 4, phi equal to pi by 2, theta equal to pi by 4, phi equal to pi by 2 and theta equal to pi by 4. So you got this cos 90 degree equal to 0 and it left two components, 1 by root 2 j cap minus 1 by root 2 k cap. So this is the answer. Okay, so now the question is, in another problem, if you have to find that phi cap, how you can find? That is 1 by r sin theta del r by del theta. So if you put this r means this one, okay, r sin theta cos phi I cap, r sin theta sin phi j cap and r cos theta k cap. So if you put this to find out phi cap, you will get minus sin phi cos phi. मैंने इधर ये सब कुछ इसलिए डाला है ताकि अगर कोई और भी क्वेश्चन आए तो आप लोग कर पाओ. ठीक है, ओके. That is, if a vector having component I, j, k, that is, if a vector it is in Cartesian coordinate. अगर कोई वेक्टर कार्टेशियन कोऑर्डिनेट में है तो उस वेक्टर को हम r थीटा फाई में कैसे लेके जाएंगे. सपोज इन एनी क्वेश्चन कोई एक वेक्टर दिया हुआ है whose components are ax, ay, az. ओके, दिस ax, ay, az एंड इसको हमें ट्रांसफॉर्म करना है कहाँ पे? स्फेरिकल पोलर कोऑर्डिनेट में. कहाँ पे? r कैप, theta cap and phi cap पे. That means AR, A theta and A phi are the components of in this direction. So ये ट्रांसफॉर्मेशन कैसे होगा? वो ऐसे होगा कि AR, A theta, A phi equal to, so इधर ये होगा ट्रांसफॉर्मेशन मैट्रिक्स. ओके, ये होगा ट्रांसफॉर्मेशन मैट्रिक्स. अंडरस्टैंड? ठीक. नेक्स्ट क्वेश्चन, कंसीडर ए सिलेंडर ऑफ हाइट h. इसका हाइट जो है ये h है एंड दिस रेडियस इज a. Closed at both ends, okay, centered at origin, okay. Let r the position vector be position vector and n cap be a unit vector normal to the surface, okay. The surface integral r dot n ds over the closed surface of the cylinder. Okay. तो इसको कैसे करेंगे? See, it's a, so how can you solve that? See, it's a very simple thing. The surface integral is r dot n ds. So by vector divergence law, what we know? R dot n cap ds equal to del dot r dv. Okay, del dot r means del x I cap plus del y j cap plus del z k cap dot x I cap plus y j cap plus z k cap. Okay, so here del dot r will give you 3. Okay, and the integration of volume dv. Okay, now ये जो cylinder, now the volume of the cylinder is pi a square h. A is the radius of that cylinder and h is the height of that cylinder. Okay, so the answer is 3 pi a square h. Next question. So if a force F is derivable from a potential function VR, where r is the distance from the origin of the coordinate system, तो क्या होगा? See, F is derivable from a potential of V. That means F equal to minus grad V. Simple. Now, if you do that del cross F. So del cross F means curl of V is equal to 0. So this one is the correct answer. Simple as that. Okay. Next one is the unit vector normal to the surface this at the point P111. Okay, so we have to find out the unit vector on the surface this one. This is our function basically. So it is x square plus y square minus z equal to 1. So what we have to find out the unit vector normal to the surface. What is that? N cap is equal to grad phi by modulus of grad phi. Simple. Unit vector normal to the surface is grad phi by modulus of grad phi at the point of 1, 1, 1. So we just did that. Here the phi equal to x square y square minus z. It is given. Okay. So if you do that grad phi, you will get 2x I cap 2y j cap minus 1 k cap. So grad phi equal to this, you can get, just put x value 1, y value 1, z value 1, and you can get this vector. Now the modulus of this, what is the modulus of this vector? It is 3. So the unit vector is grad phi by modulus of grad phi. Okay, done. समझ में आया क्या? ठीक है. Okay. So now, next question is identify the correct statement for the following vectors A and B. Okay, the vectors are A, B linearly independent. Okay, linearly dependent, orthogonal, normalized. Okay. So see, first one is if it is linearly independent. If it is linearly independent, then if we write the vector as a column, suppose this is the A vector. The x component is ax and y component is ay. So ax, ay. Basically, the first one is a vector, okay, and the second one is b vector, that is bx and by, and we are writing this vector as a columnar matrix. Okay, if you calculate the determinant of this matrix, if it is not equal to 0, then you can tell that it is linearly independent. As simple as that. So if any vectors are given a, b, c, d, whatever it is, just write down in a columnar form. So suppose ax, ay, bx, by. Suppose there is any another component is there, bz, cx, cy, cz. Just find out the determinant of this vector. Okay, so just find out the determinant of the vector. If it is not equal to 0, then we can say it is linearly independent. As simple as that. Okay, and if it is 0, then it is coming out that it is linearly dependent of one another. Okay, so here if you can, here I can write that ax, ay, that means 3, 2. It is 3, 2, and second one is 1, 2. Second one is 1, 2. If we calculate this, it is coming not equal to 0. So they are linearly independent. ठीक है, समझ गए? ठीक है, चलो next question. हाँ, okay. So if a and b constant vector, then grad of a dot b cross r. एकदम सिंपल है रे. देख, a dot b cross c equal to b dot c cross a equal to c dot a cross b. So now अभी ध्यान से देखिए इस चीज को. a dot b cross c it is. Suppose a dot b cross c. So what we can write? C dot मतलब r dot, okay, a cross b. So we just write this, okay, कि a dot b cross c equal to c dot a cross b. Now, okay, got it? So now a and b are constant vector. Okay, so a and b are constant vectors. So a cross b also a constant. Okay, and what we know कि ग्रेड के अंदर अगर कांस्टेंट इनटू कोई भी वेक्टर होता है, कांस्टेंट इनटू कोई भी वेक्टर अगर होता है, सो इट विल गिव यू द कांस्टेंट वेक्टर. अंडरस्टैंड? So what is constant here? A cross b. So grad r dot a cross b will give you a cross b. This is the right answer. You can directly calculate. This is the second method. You can directly calculate like this, that a equal to ax I cap ay j cap az k cap, and b equal to bx I cap by j cap bz k cap, and r equal to x I cap y j cap z k cap. Okay, you can directly calculate. Directly calculate means you find first you find a cross b, a cross b, then give this r dot, and then you calculate grad of this thing. If you can directly calculate this, and you will get the same answer. Okay, chalo. Next question, the unit vector perpendicular to this surface, this at the point 1, 1, 1. This is the same kind of question we already solved. That is, the unit vector is grad phi by modulus of grad phi, and phi means this surface x square y square plus z square minus 3. So this surface is phi. So just put this phi value. I mean phi x square plus y square plus z square minus 3. Okay, so if you put this phi, grad phi, you will get 2x I cap, 2y j cap, 2z k cap. Just simple one line calculation, and put x, y and z values 1 1 1. You will get 2y cap, 2j cap, 2k cap. Okay, now find out the modulus. Okay, the modulus is root over 12 or 2 root 3. Now put the values here and you will get this unit vector. Okay, done. See, this is again the same kind of question. The direction of grad f of a scalar field at the point P112. So the direction of grad f means what? The grad f divided by modulus of grad f. Simple thing. Okay, and if we already, and f is already there, a half x square minus xy plus half z square. Just calculate this grad f. If you calculate this, you will find this this one, x minus y I cap minus x j cap plus z k cap. Now put the values 1 1 2 and you will get this, come up with this vector minus j 2 k cap. Now find the modulus and you will get 1 square, basically minus 1. Okay, so it should be minus 1 and minus 1 square. Okay, anyway, so it is root 5. So put these values and you will get this. So what is the answer? Minus j plus 2k. Minus j plus 2k by root 5. B is the answer. Okay. Now, given f equal to r cross b, okay, b equal to this one constant vector, okay, r is the position vector, okay, find the value of f dot dr. Same thing. See, the question is coming like that. You have to understand here. We already solved this question. We already solved this kind of question. This is where it is. It is there. See, it is r dot n ds. It is surface integral. So here we use vector divergence law for surface integral. In the same way, here we will apply that. Here we will apply this law. The f dot dr equal to del cross f ds. Okay, f dot dr equal to del cross f ds. Understand? Okay. So del cross f dot ds dot, here it will be dot. Okay, so put that values of r, x, y, z, and b is constant vector b0 b0 b0. You will find that del f equal to this one. Now find del cross f. Del cross f will come this one, minus 2y plus 2j plus 2k b0. And in cylindrical coordinate, okay, say surface area. In cylindrical coordinate, what is this surface? Along the k cap, because it is the cylinder. If it is the cylinder, if it is c cylinder, the direction is upwards. Okay, it's upward along the z direction. Okay. So here, if you dot product this del cross f dot ds, what you will get? This one is del cross f dot ds. ds is along the z direction or along the direction of k. Okay, so this k and k will dot, and you will get this one value. Okay, now put the limit value, that r equal to 0 to 1 and theta equal to 0 to 2 pi, because it is cylindrical coordinate and a circle of unit radius, it already given. Okay, so r equal to 0 to 1 and theta equal to 0 to 2 pi for cylindrical coordinate. You will put these values, you will get this, and the solution is this, minus 2 pi b0. Understand? Okay. ठीक है, नेक्स्ट क्वेश्चन में जाओ, चलो. Okay, so this one is v1 equal to I minus j, v2 equal to minus 2i plus 3j plus 2k. Okay, which one of the following v3 makes a complete set of 3-dimensional linear vector space? Okay, so first you have to know कि 3-dimensional real linear vector space बनाने के लिए the required thing is these 3 vectors should be linearly independent. Okay, it should be linearly independent. So how can we write? See, we already did this in another question, that just columnar, you just write the vector in a column wise. Okay, suppose this one is v1, so first one is vx, that is 1, vy, that is minus 1, and vz equal to 0. Okay, this is the first vector, this is the second vector, and this is the third vector. Now if you now what we are going to do, put these v3 values here. Okay, and calculate in which case the matrix come not equal to 0. Determinant of this matrix come not equal to 0, we can say this V3 will form a 3-dimensional real linear vector space. Understand? So just put the values. Okay, so if we put this 2i plus 2i plus j, 2i plus j plus 4k. Okay, no rocket science is there. Just put one by one this vector, and you can see this V3, option D V3. you are putting there, you will get it is not equal to 0. Determinant A is not equal to 0. So you can say this V3 will make 3D real linear vector space with this V1 and this V2. समझ गए? ठीक है, हो गया? कोई क्वेश्चन? बताओ. एनी क्वेश्चन? बताओ. सो नेक्स्ट क्लास में कौन सा टॉपिक करना है मुझे नीचे कमेंट्स में बताना. सपोज कॉम्प्लेक्स, इफ इट इज कॉम्प्लेक्स नंबर, और फूरियर एनालिसिस. ओके, फूरियर एनालिसिस, और व्हाट काइंड ऑफ, और डिराक डेल्टा फंक्शन. Lots of students are facing problem solving differential equation. Okay, so just let me know in the comment, and I will solve all the previous year questions for those chapters for 10 years. Okay, 10 years I will solve this and explain to you. And if you have any doubt, any question, just let me know in the comments. I will try to answer them.